I also want to review very quickly the Lagrangian method that we did. I want you to put both of them on the same paper, right on top of each other, so that you have them with you every single time we do a problem. The two things you should write the Lagrangian formalism and the Hamiltonian formalism on a single piece of paper somewhere where they are very easily accessible to you. Let me review what we did for Lagrangian. And honestly, it'll seem very simple now after this mess. So Lagrangian formalism. What was Lagrangian formalism step one? Do you guys want to look at your step ones? That's it. Step one was just write it down. Number two, choose a suitable set of generalized coordinates that uniquely specify your system. Number three, get kinetic energy as a function of these coordinates. Number four, find the correct V depending on your system. Number five, put T and V into equation A. Let's call this equation A. And number six, use Euler-Lagrange equations suitable. And what were the two Lagrangian equations? D over dt of partial over partial q dot L minus partial L over partial q equals 0. Or d over dt of partial L over partial q dot minus partial L over partial q equals some force. Let me just call it F. And then I can do I's to represent the number of coordinates that are required. So let's say there's only one coordinate required. How many equations should you have? One. If there are two, then there will be two, there will be three, so on. When do we use equation one? I call this equation one. When do we use equation one? Conservative system. And when do you use equation two? When you have a non-conservative system, where F is what kind of force? The force that arises due to resistance, friction, drag, something, right? It's not the applied force. It's never going to be the applied force. It's going to be the force that arises because in your system, some resistive force is present. Because the subscript, all that's telling you that I goes with the number of coordinates. I'm going to do one small thing to prove that Lagrangian formalism is not new. If I say that this is not new, that means I should be able to develop equations of motions from these two equations that I've given you. So let's do that really quickly. So I said we have to find the correct V. So the simplest solution is the correct V, which we call free space. So if I have the situation of, for a free space, potential equals 0. What does T, and I'm only looking for one coordinate. So there's my one particle and it's just moving in a straight line. So what will be T for this expression? 1/2 mx dot squared. What is T for this expression? It's not moving up or down. It's just going in a straight line. What's V for this? So then how will I write the Lagrangian? So far, so good? And consider a completely conservative system. So for a completely conservative system, which equation should I use, 1 or 2? 1. So I will get d over dt of partial L over partial x dot minus partial L over partial x equals 0. All I did was I looked at my system. It's only moving in 1D. Can I write equation 1 like this? What is then d over dt of partial L over partial x dot? So what will be partial L over partial x dot? Right? Can I plug that in here? What is partial L over partial x? Is there a value of it? No, there isn't. So that means this is going to be 0 equals 0. Mx double dot equals 0. Everybody clear on how we got that? That means what? The acceleration in the system is 0. That's my simplest case, right? Okay, next situation. What if there is a potential present? I just don't know what it is. What happens in that case? For when potential is there, say V, how will this situation change? I will get d over dt of partial L over partial x dot minus partial L over partial x equals 0. Same situation, I will get d over dt of mx dot minus partial v over partial x equals 0. Oh, actually, no, hold on. What will my L be in this case? My L will be t minus v, right? So this would become a minus here. Partial L over partial x. What is partial xt? Does t have any term that has x in it? So that goes to 0. Okay, so we all know where this minus came from, right? All I'm doing is plugging that value in. That means I can write this as mx double dot plus partial v over partial x. In this case, can I change the partials to full derivatives? Yes? So that means I can rewrite this as minus dv over dx. What is this? Isn't this force? And what is this? Isn't that also force? We wrote this as minus del of u. Did we not? That means this formalism works. Woohoo!